Every scientist at some point is going to have to figure out what it is that motivates them, because science is mostly failure. I think it's the ability to know the truth that drives most scientists. Every little piece of truth that you uncover helps someone else to uncover more of the truth. So there is very little of science that is not used to build more discovery. I actually had never had the idea about glowing cells until I got down to University of Tennessee and started working with Dr. Gary Saylor. The project was presented to me as a high-risk, high-reward opportunity, which as a graduate student you think is fantastic because you're the best and the brightest, and there's no way that it won't work. When we first started, the state-of-the-art for our technology was that we could use light to make cells talk. And they could tell us, I feel good or I feel bad. And they were limited to really just telling us at one instant in time. The project that we built was, how do we get the cells to not give us just a yes or no, but actually have a conversation with us? Within the community, it was so widely accepted that what we were trying to do wasn't going to be possible. What was impossible was that we could find a way to make the cell produce light continuously without using up all of the cell's energy, and to automatically change how much light it's making to tell us whether or not it's sick or healthy. We were willing to let ourselves look like fools trying something that most people would say, why would you even bother with this? Because to do something unconventional, you have to build it unconventionally. This is it. This is where I spent 5 years of my life working in here, day and night, looking back what seems like almost continuously. Right over there is my bench where everything started. There were a lot of long nights in the lab where you ask yourself, is this going to be worth it? There was a lot of times where I thought, maybe this won't work because I just don't know enough myself to make it work. One of the challenging pieces about approaching a project unconventionally is you're forced to constantly work outside of your comfort zone. So I often found myself trying to learn new techniques at night, trying things out during the day, and really running from one lab to another, from one bench to another, from one piece of equipment to another. It was a process that left me spinning. When you experience difficulties in that type of a situation, the doubt that creeps in isn't, I'm doing something wrong. The doubt that creeps in is, maybe this is actually impossible. I remember I was walking to lunch with some other graduate students after a series of failed experiments. And in this spot was the first time that I thought to myself, maybe what we're trying to do is actually impossible. Maybe it's just not going to work. But it takes 24 hours from the time we start an experiment until we know the results. So in the lab, there were things happening that I wasn't even aware of yet.
Dan Close has struck gold. The product? Cell lines containing genes that glow naturally. The researchers use a series of genes to trigger this phenomenon from human or animal cells.
the immediate feeling that I had was relief. After working so hard for so many years, we had just taken the project and moved it from the impossible to the possible. When we first tried to publish our findings, we actually had a reviewer who rejected our paper without even reading it, saying, well, obviously what they're doing isn't real because it's impossible. And the whole point of the paper was, look, we found a way to make this possible. And on the other side of the spectrum, we had labs from all over the world emailing us wanting to use it for applications we had never envisioned before. And it was that continued tide of requests that eventually pushed us to say, well, we're going to have to put this in a format where these people can take advantage of it. Now it's a science project again. How do we make it better? How do we make it do these different things? Our technology provides better scientific information, and it's also less expensive and easier to use. We've seen people use the technology in regenerative medicine applications to help grow new bone or tissue cells where a wound has occurred. We've seen it in cancer research to look at how drugs are treating cancers. We've even been fortunate to launch the technology into space and look at how it helps take advantage of microgravity for long-term spaceflight applications. At the core of what we do, we've always had the idea, how do we help people solve the most challenging problems? And we've built everything out from that idea. I absolutely think that we could change the world with this technology. We have the ability to make people's lives better, and that's very powerful to us. And our motivation used to be, let's prove to the world that we can do this. And now our motivation is, let's use this to give back to the world.